Hello everyone, good day. Today's video will talk about predicates and quantifiers. So when we say predicate, it is an expression of one or more variables that define on some specific domain. So for example, let Px denotes x equals to y. So when we say quantifiers uh, is a words that refers to the quantities such as sum and all, and tells how many elements a given predicates is true. So the common example of quantifiers that we are using is existential quantifiers and universal quantifiers. And so when we say nested quantifiers, it refers to the two quantifiers that the one quantifiers is within the scope of another quantifiers. So for example, universal x and existential y. So if we transform that into an English statement, that will be for every x there is a y. So, another example, existential x and universal y. So if we transform that into the English statement, that will be there is an x for every y. So that is the meaning of predicates, the quantifiers, and the nested quantifiers. So our statement is qx equals x plus y is greater than 2x. So our first given value of x is 0. So we'll substitute 0 in our x. So since it is 0, 0 plus y is greater than 2 times 0 because it has an x. So the answer is 0 plus y. Since it is only a variable, so it is equivalent to 1. So 0 plus 1 equals 1. The greater than 2 times 0 is 2 times 0 is 0. So therefore, this statement x plus y is greater than 0 and the value of x is 0 is true because 1 is greater than 0. So our next given value of x is negative 1. So we'll substitute the value of x. So x and negative 1 plus y is greater than 2 times negative 1. So here's negative 1 plus 1, since it is variable only, so it is equivalent to 1. So negative 1 plus 1 is equals to 0. Greater than negative 2 times negative 1 is negative 2. So therefore, this statement is true because 0 is greater than negative 2. So the next given value of x is 1. So we will substitute the value of x. So 1 plus y is greater than 2 times 1. So 1 plus 1 is 2. Is greater than 2 times 1 is 2. Therefore, it is false because 2 is not greater than 2. It is equal to. So our next given problem is existential x qx. This statement can be perceived as existential x universal y, then p x plus y is greater than 2x. So I will let negative 2, negative 1, 0 be the value of x or x, and y be the value and y is 2, 1, then 0. So first we will substitute the value of x and y. So first we will substitute negative 2, then 2. Negative 2 for the x and 2 for y. So negative 2 plus 2 is greater than 2 times negative 2. So negative 2 plus 2 is equal to 0. Then greater than negative the 2 times negative 2 is negative 4. So therefore it is true. The next we will try negative 1 then 1. So negative 1 plus 1 is greater than 2 times negative 1. Negative 1 plus 1 is 0, then greater than 2 times negative 1 is negative 2, then our statement is true. The last one, 0. So 0 plus 0 is greater than 0 plus 0 is greater than 2 times 0. So 0 plus 0 is 0, then greater than 2 times 0 is 0. So therefore, our statement is false because 0 is not greater than 0. So this statement is true because in existential, it can be true if one of the truth values is true. So next is universal x qx can be perceived as universal x existential y px plus y is greater than 2x. So if we read this in English statement, for every x there is a y such that px plus y is greater than 2x. So we'll let the value of p be the negative integer. So we'll let negative 3, negative 2, negative 1. This is for x, and y is a positive integers because y here is the countermeasure of x, so that our statement will be true. So we'll put 3, 2, then 1. So we will put the value of our x and y. So our x is negative 3 plus 3 is greater than 2x, or 2 negative 3. So negative 3 plus 3 is 0 is greater than negative 2 times negative 3 is 6. So therefore it is true. So the next is negative 2. Negative 2 plus 2 is greater than 2 times negative 2. So 2 minus negative 2 plus 2 is 0 is greater than negative 2 minus 2 times negative 2 is 4. So therefore it is true. Next will be negative 1. Negative 1 plus 1 is greater than 2 negative 1. Negative 1 plus 1 is 0 greater than 2 times negative 1 is 2. Therefore, it is true. So our statement here is true. Our next given problem is existential n ix negated qx. This can be perceived as existential x universal y negated p x plus y is greater than 2x. So we'll let the value of n be negative 1, 0, then 1. Value for x. Then for y is the same. We'll put negative 1, 0, then 1. So we'll substitute the value of x and y. So first, negated negative 1 plus negated negative 1 is greater than 2 2 negated negative 1. So negated since it is negative, so it will be positive. Same for this, plus 1 is greater than, since it is negative, it will go positive. 2 times 1, so 1 plus 1 is 2, greater than 2 times 1 is 2, so it is false. The second one, 0 plus 0 is greater than 2, then 0. So therefore 0 plus 0 is 0, greater than 2 times 0 is 0, so it is false. The next is 1. Negated 1 plus negated 1 is greater than 2 negated 2. 1. Negated 1. Negated 1. So therefore, negative 1 plus negative 1 is greater than 2 times 1. So therefore, negative 1 plus negative 1 is negative 2. Is greater than 2 times 1 is negative 2. So therefore, it is false because negative 2 is not greater than negative 2. So this statement is false. So our next given value is universal x negated q x. This can be perceived as universal x, then existential y negated p x plus y is greater than 2x. So let the value of x be 3, 2, 1, and the value of y is negative 3, negative 2, then negative 1. So this is x, this is y. So since we'll substitute the value of x, so here we have 3, since negated plus negated negative 3 is greater than 2, then negated 3, then since this is positive, will be negative. So since it is negative, so it is positive. So greater than 2, Since it is positive, so it will be negative. So 3 plus 3 is negative 3 plus 3 is 0. Then 2 times negative 3 is negative 6, so it is true. Another negative 2 ah 2 sorry 2 negated plus negated negative 2 is greater than 2 negated 2. Since it is positive, it will be negative 2 plus 2 is greater than 2 negative 2. So negative 2 plus 2 is 0, greater than negative 2 times negative 2 is 4, so it is true. Next is 1 negated plus negated negative 1 is greater than 2, then negated 2. Since it is positive, since it is negation, so negative 1 plus 1 is greater than 2, then negative 1. So negative 1 plus 1 is 1. 0 is greater than 2 times negative 1 is 2, and negative 2. So therefore, it is true. Our statement is true. We will determine the truth values of this statement if our domain is all integers. So our domain here is n. So we will let negative 2, negative 1, 0, 1, then 2 be the value of our domain. So our domain is negative 2 plus 1 is greater than, so since it is negative 2, our value of domain, so here also is negative 2 plus 1 is greater than negative 1 plus 1 is greater than 0. 1 plus 1 is greater than 1. 2 plus 1 is greater than 2. So negative 2 plus 1 is equals to 1. 1 greater than negative 2. Negative 1. Negative 2 plus 1 equals negative 1. So negative 1 is greater than 2, so it is true. Negative 1 plus 1 equals to 0 is greater than negative 1. So another true. Next, 0 plus 1 equals 1. 1 is greater than 0. So it is true. 1 plus 1 equals 2 is greater than 1. So true. 2 plus 1 equals 3 is greater than 2. So it is true. So therefore, this statement is true. So our next given value is existential n, and 2n equals to 3n. So our domain here is n. So we will let the value of n equivalent to negative 2, negative 1, 0, 1, then 2. So we will put the value of n. So since we have already the value of n, so we'll just put 2, then negative 2 equals to 3, then negative 2. Next is 2 times negative 1, then 3, negative 1. 0. 2 times 0, then 3 and 0. Next is 2 1, then 3, 1. Next is 2, then 2, 3, then 2. So 2 times negative 2 is negative 4. Negative 4 equals 3 times negative 2 is negative 6. So therefore negative 4 is equals to negative 6. So it is false. False. 2 times negative 1, so it is negative 2. Equals 3 times negative 1 is negative 3. So it is another false. 2 times 0 is equal to 0. Then 3 times 0 is equals to 0. So it is true. 0 is equals to 0. Next, 2 times 1 is 2 equals 3 times 1 is 3. So it is false. The last one is 2 times 2 is 4 equals 3 times 2 is equals to 6. So it is false. So in existential quantifiers, we can only put this statement true if one of these statement has a truth values. So since we have a true value here, so therefore this statement will be also true. So our third given problem is existential n and n equals to negative n. So we will let negative 2, negative 1, 0, 1, then 2 be the value of n. So we will first substitute our given value n equals to negative 2, negative 1, 0, 1, and 2 equals to negative 2, then negative 1 equals negative 0, and then negative 1, negative 2. Negative 2 is equals to, since it is both negative, so it will go for positive. It will be positive, so it will be positive 2. So negative 2 is equals to 2, so false. Negative 1, then negative times negative, so positive, so 1, positive. So another false. Negative 0, negative times 0, so 0, it will go for 0 because there's no negative 0. So therefore it is true. 0 is equals to 0. Next is 1 equals to negative times positive, so it will be negative. So negative 1. 1 equals negative 1, so it is false. Then the last one, 2 equals to negative times positive, so negative 2. 2 is equals to negative 2, so it is false. So therefore, since it has a 1 truth values, so therefore their statement will be true because one of the truth values is true. So our next given problem is universal n and 3n is less than or equal to 4n. So we will let negative 2, negative 1, 0, 1, 2 be the value of our domain. So next we'll substitute it. 3, negative 2 is greater than or equal to 4, then negative 2. Next is 3, negative 1 is greater than or equal to 4, and negative 1. Next is 3, then 0 is greater than or equal to 4, then 0. Next is 3, 1, then less than or equal to 4 times 1. Then last 3, then 2 is less than or equal to 4. Then so 3 times negative 2 is negative 6 is less than or equal to 4 times negative 2 is negative 8. So therefore, negative 6 is less than or equal to negative 8. So it is false. It is false. Next, negative 3 times negative 1 is negative 3 is less than or equal to 4 times negative 1 is negative 4. So it is false. 0 times 0 is equals to 0. Is less than or equal to 4 times 0 is 0. So therefore, it is true. Next, 3 times 1 is 3. 3 is less than or equal to 4 times 1 is 4. So therefore, 3 is less than or equal to 4. So it is true. 3 times 2 is 6 is less than or equal to 4 times 2 is 8 is true. Therefore, this statement, since it is universal statement, universal quantifiers, in universal quantifiers, we can only put true if all the truth values are true. So since it has a false value, a false truth value, so it is false. We will express this statement using predicates and quantifiers. So our statement is there is a student who has taken more than 21 credits hour in a semester and received all A's. So let PX represent a student who has taken more than 21 credit hours in a semester and let qx represent receive all A's. So this statement can be transformed into there is an x, p, x, and q, x. This statement can be transformed into this. In every student who has taken more than 21 credits hours receive all A's. It can be also transformed into this form. There is an x, p, px, and there is x, q, x. It can be this form or it can be this form. So I will clear this. There is an x, p, x, and there is x, q, x.